battery. We have a Macbook A1466 and it says it doesn't detect the battery. Okay, so let's see. This is not coming from directly from the client. This is coming from a company, which means it has already been pre-diagnosed. So this is not one of the designs. The MacBook is it's not one of the designs that has a dual battery management, so it's just the battery directly connected to the board. So if you have a case where the battery is not detected, that's what they're saying now, the first thing you want to do is you want to put in another battery to see what you get. Okay, we might have to put through a test drive, or so the reason why we might have to put through a test drive is just to see if the battery itself, we see the battery icon and then it says you have X on your battery, so that X on your battery. So in this case, if we disconnect the battery, so with battery issues, there are times where the battery is detected but it's not charging. And there are times where the battery charges, but it's not detected. But then the second one, it's not possible without the first one. In order for the battery itself to charge, it needs to be detected. So we are not gonna, so if you have a case of the battery not charging, you have to address, you have to address, so you have a case where the battery is detected, but it's not charging. However, if the battery is not detected, then you will not even have to worry about charging. Do you understand? So you will have a case whereby the battery itself is detected, but it doesn't charge. It doesn't increase. Whatever you have it on, whatever percentage you have the battery on, that's what you plug the charger in. It remains on that percentage. In that case, you're dealing with the battery. The battery itself is detected, but it's not charging. But in the case of the battery not being detected, you are not going to worry about the charging circuitry of the battery. First thing first, what you do is to get the battery to get the machine to detect the battery, because the battery needs to be detected before it can initiate charge. Do you understand? Because it makes sense for the battery, for the machine to detect the presence of a battery before it charges. So right now it says the battery is not detected, so which would mean that if we disconnect the charger, it should go off. Okay, so the first thing we're going to do is we're going to try with a different battery. This is coming from a repair company. I'm going to mention that. The reason why I'm repeating that is, which means that they have put in a different battery to test it. But just so that we see, just to confirm that, that's the case, we are going to put in another battery and see if that solves the problem. And I don't think that will solve the problem, and if it does, it's really going to be annoying, because I mean that wouldn't be the case, because the guys that does the assessments, they are very competent, so that will not be the case. We are only going to confirm that indeed. Sometimes, very rare, it may also be that the battery that you use in your testing is faulty. But that's very rare, because if they use a used battery, it doesn't work, chances are that they will use a new battery, which and I also do not believe that they will settle for just one battery. Nonetheless, we are going to test with another battery, see if that if the issue persists. So let's see this. See if okay, so this one, the battery is actually full. I mean, because it's green. So nah, went back to amber. Okay. Let's see what we get on this one. It's a whole lot of time wasted. If the fan overspins, that might just tell us exactly what might be going on. I can hear the fan, it's super loud, so I'm not sure if that is an issue yet. But if you have a fan being super loud and the battery not being detected, the battery is still not detected, because if it was detected, we should have it here. The battery is still not detected, which would mean that if we are to, okay, we can just restart, just restart it in order for it to go to desktop. But if this is true that the fan is loud, that might just give us a straight clue that the issue that we're having has to do with the SMC region, because that will be a perfect combination of battery not being detected, and then you also have, yeah, so if we remove the charger, it should go off. Let's see. Yeah, so it just goes off. Okay, so this might just be an issue with the SMC. The SMC data line. Let's see what it is. Let's quickly take the board out. Because of the sensor, SMC plays a role in the fan control, and if you have a section of SMC, if you have an issue on the sensor line, which is going to come from the SMC, and then at the same time you have the battery not being detected, that will tell you that indeed you may just have to go straight to your SMC. Nonetheless, what we are going to do, it's first thing first, we are going to see what is it that we have on our PP bus. Remember when I said that, so when it comes to the battery charger now, so so with the battery, let's see how we troubleshoot for battery. Now this is our battery connector, which is J4800, correct? On J4800, let's go to the schematic of J4800. J48, is it 4800?
Yeah.
J4800. Okay, so is it now? That's trackpad. I think we missed it. It's here. J69. J6950. Okay, J6950. By the way, usually on your schematic, the J will stand for connectors. Whenever you see J, that is to be used to refer to connectors. Okay, so let's see. Let's go to the connector. So this is the battery connector. On the battery connector, in terms of the battery not being detected, we are going to worry about these two: SM bus, SMC, and SMC underscore. SM bus, SMC, SCL, SM bus, SMC, SDA. So that's where we're going to worry about, because there has to be a communication between those two lines in order for the SMC to basically allow the battery to work with the machine. Though you see on that batch on your connector, you will have the PP bus battery, which is, you see where it says PPV bat, that is the battery voltage that you will find on pin 1, pin 2, and pin 3. And then pin 4 is where you find the SM bus. Now this should be around about 3 point something volt, and then on the SMC, and see here is a bi-directional line between the SMC as well as the connector itself, which then allow it to communicate with the battery. So our primary concern is going to be between 1, 2, and 6 detect L, but primarily we are going to worry about, especially if you have the fans going crazy, because if 6 detect L was a problem, then your fan wouldn't ramp loud. So let's just try it again, just to confirm that the fans are ramping up loud. And then at the same time, we are also going to see what is it that we have on our PP bus. If it's 8.6, then at least in the PP bus is set to be okay. But if it's 8.2, then you definitely know that the SMC is something that you have to worry about. But first thing first, let us see if we're going to check for two things. If okay, it is on. The amber light is quite. Let's flip it to the other side. Okay, so let's see, what do we have on our PP bus? Is it 8.6 or 8.5? 8.1. So that's straight an SMC issue. Because if it was, so remember the other previous stream I was telling you that if it's 8.2-ish, yeah, and then you will have a case of battery not charging. So this is just an SMC issue. So it might be on a data line itself, or it might be the SMC itself. So this should be 8.6, not 8.1, 8.2. So this is why the battery is not charging. So we're just gonna go straight to the SMC. And usually just reflowing the SMC will fix the problem. So you remember when I was saying on the other stream that even though you happen to have the board starting, the board will start, but you have your SMC, so you have your SMC still on 8.2, which means you will not be able to charge the battery, which will come from the battery not being detected. And then I see that it seems there's been an activity around the SMC. See that? So there's been a reflow around SMC, and not just a reflow actually. I see that resistor. Yeah, there's been work around here. So two things, like I said, it may be that we have an issue here on the SMC SCL line or SDA line, so clock line and data line. So let's first of all, so it could be an issue with the SMC itself, which is this guy, or it could be an issue with the pull-up resistors for the SCL and the SCL and the SDA lines. So let's check that. So we are going to, especially because we see here, I mean, there's been activity. See this guy here, this resistor here, that's a pull-up resistor for your, yeah, these two guys here. So we are going to see what those two guys are, and then we are going to be very concerned about this, the voltage that is here. It must be present here to make sure that there's no broken line, and then the voltage at here also must be present there. So let's go to the region of the SMC. Now I was pointing at these two resistors. This one, you see what this says? SM bus, yeah. SMC G3, and then SMC SDA. So I'm going to be making sure that the line is not broken between, because if the line, so it's a pull-up from PP342. Now if you have a broken line between this point here, it would mean that 3.42 volt is not making its way to the SMC, and this one as well. So we are going to be checking these two, 1 and 2, to be sure, to make sure that we have 3.42 volt there. So that will be, we're going to check here and here. So this will be for this, and this will be for this. And if we have 3.42 volts there, then we may have to reflow the SMC. So it's we can as well check for, first of all, we can as well check this two here, because you're supposed to have SDA and SCL there as well. So also see what is it that we have there. Okay, let's just confirm that we still have 8.2, 8.1. Yeah, okay. Yeah, okay. Now let's see, do we have on our SC on an SDA 3.3? That's fine. And then the other one, okay, that's fine. So let's check this part here. Do we have? That's fine. And then the other one, which is here, and that is also fine. Okay, so we'll have to reflow the SMC. So if we didn't have 3.4 volt on that part and this part, we will have to worry about the resistors, correct? But now that we have the 3.4 volts there, it means that they are doing their work. They're putting up this 3.3 volt to 3.2 in order for us to get 3.4 volt on the other side. So we're just going to reflow the SMC. So let's do that. Now to reflow the SMC, we are going to remove the edge bonding first. And if reflow doesn't work, we are going to replace it. First thing we're going to do is to remove the edge bonding. Okay. Okay, so we have reflowed SMC. If that doesn't work, then we are going to replace it. So I'm just gonna, you can just check here again. So here, if we had less than 3.4 volt here and less than 3.4 volt here, the reason why that is this. So this resistor here, this R5380, will pull up 3.42 volt to 3.4 volt on the other side, which will also make its way to the SMC. Now, if we saw that there was previous work here, it seems there was some kind of liquid in this section which damaged the pad for which is why they probably replaced R5381 and R5380. Now, if these two are replaced, even though they are replaced, you might have 3.42 volt here and a 3.42 volt there. But if there is a broken pad between this and that, then it will mean that most likely there is also a broken pad between that point and the SMC. And if that happens, you will also have a case of the SMC not performing because the pull up, the 3.42 volt pull up is not present. Now, because we checked that we have the 3.42 volt here and there, then the only thing we then that is why we didn't have to blame or fault the resistors, but only fault the SMC. So we have reflowed the SMC. We're giving it a bit of time to cool off. If that doesn't fix it, we are just going to replace the SMC. And then another thing is now in this situation, another way where you might also have the SMC reading 8.2 will be when the SMC is in reset L. So if this signal here is low, let's see, SMC reset L. if this signal here is low, SMC reset L, so you're supposed to have 3.42 volt here. Now if this signal is, if this signal is low, then you will also have a case of your PP bus becoming 8.2 and not 8.6. However, the difference between your SMC being low and the state of the board is, if SMC reset L is active, the board will not start at all. Do you understand? But in this case, the board is still starting, and then we are not able to charge the battery. But what I'm trying to say is, when this SMC reset the L is active, you will have less than 3.42 volt here. When you have less than 3.42 volt here, your PP bus will read exactly what it was reading, what this board was reading, which will be 8.2, 8.1-ish to 8.2, not 8.6. Now the difference between if the problem is that the SMC reset L is low, is that if that is the case, the board will not start at all. Yeah, okay.
So the board starting means there's not a problem there.
Yes, there's no problem there, yeah. Even though, because if you had a problem there, you will have a case of PP bus being 8.2, but in that state, the board is not going to power at all. And another thing is, also when the SMC reset L is low, when you connect your charger, the charger will only remain amber and will never transition into, it will stay on green and will never transition into amber. So, but then the flip side of now, in case you are not sure, let's say the device comes to you and then you connect your charger and then you're not sure it stays on amber, also take note that it might just be that the battery itself is fully charged. So you want to disconnect the battery and see if it still stays amber. If it still stays amber, then that is when you want to start to connect the dot to say, okay, maybe you have an SMC being in reset mode. So that is that. So now we are now going to see what is it that we have on PP bus. Let's see if we still have 8.2 or we have 8.6. Okay, we have fan Spain. Let's see, what do we have? Okay, we still have 8.1. So the next thing we are going to do is we are going to see if we are going to remove the SMC and see if the 3.42 volt is making its way to, so here, this one here, we want to see if it's making its way to pin 148, and then the other one as well, we want to see if that is making its way to pin 147. So we're going to remove that, remove the SMC. Okay, the SMC is out. So what we're going to do now is we are going to check. We're going to confirm that we have continuity between pin 147 and this pad here. So we were going to check for continuity between this pad and that pad, and then this pad and this pad. So let's see. Because if you don't have continuity, that will give us the problem that we are having now. So it's from this pad here to the third one. So it's going to be 1, 2, 3. Let's see. That's fine, we have continuity, and the next one will be this one here. Okay, that's fine. So we have continuity, so we need to put in another SMC. So let's take remember the other one that we had used for the other board, and didn't give us source, but obviously we eventually found out that the problem was not it in itself. So let's use that one. Now you see the way the way this is one of the times that this is one of the times where you get a chip not being properly installed, and then you have a short on your VP3 so let's just hope that's not going to be the case, because if it is, we have to again redo it. Let's hope it flows in place without any issue. Did you see it move in place? You didn't see it? Oh, okay. Yeah, we're afraid. Yeah, definitely you have issue with your eyesight. Ask me to buy 2 glasses, because one is not going to be enough. Craig, Craig, how are you?
Good, how are you, man?
I'm okay. Talk to me.
Good. Do you have Macbook Air 2017?
2017?
Yeah.
What do you need?
Full computer.
I can build one.
Okay. Do you have all the components or all the parts put together?
I think so. I've got a board. Shahid gave my beautiful screen away.
If you have a board, how much is the board? I've got lots of shelves.
Yeah, I can just give you the board for 2.8. There's something that
Okay.
yeah, and then you can build it yourself.
Yeah, that's fine. I think I'll take that and just deduct it off what you owe me.
Not a problem. Let me know when you want it.
Will do. I'm probably going to send someone because your screen should arrive tomorrow.
That's fine. Not a problem. I'll put the board aside. Okay, he knows where the board is, so yeah, it's all good.
Okay, cool. And then also, did you sort out that screen problem?
Yeah, I've not been able to get grease. Yeah, if you can, I don't know if you can probably sort it out. I'm not sure.
I can. I've had it before. Sometimes because the hinges get so tight, you put a little bit of grease on it and move it around, and open and close. It comes right. But if you're struggling with it, I will sort it out for you.
Thank you.
Just let me know.
Okay.
Okay. Cool.
Thanks. Bye.
Thanks, man. Bye.
There's something that I'm seeing here. Did you see that the resistor popped off? Okay, I see it. So this resistor here, the one that was here, is off. So I'm not sure if that was making partial contact or it came off because if that is the case, it means the SMC itself is fine. Do you understand? It could just mean that there was it was making partial contact. Let's see. So yeah, so we have to put in another resistor there. Let's see. So you want to make sure that you scratch to get proper communication. It's actually good that it fell off, because if it didn't, we'll probably have the same issue, and we'll believe that we have proper pull-up of the resistor. Okay, so let's we can add solder to that point, and add another resistor to it. You need a smaller for this application. I doubt you can see it. Okay. Okay, I'm gonna another resistor. Okay. Okay. So that resistor is put back. So this was the one that popped off. This one here, 5380. Even though we did check and we got output from it, so I'm not sure if it wasn't properly there was no proper communication across. But it's actually good that it popped off, otherwise we probably wouldn't have delivered it, because what would have happened would have been that we replace. That's just as replacing SMC now and we still have the same issue, but then because we had already passed it, we would just assume now it's fine and then start to think about something else. Okay, so that's fine. So two things we're going to worry about now. Number one is if it's SMC is properly installed, that we can easily confirm that by to see if we have a short on PP342. Although that's not the only way to confirm that the SMC is not properly installed, but it's just like it's the easier way. Okay, so we don't have a short on the SMC. Okay, so let's see, does it start at least? Are we where we were before the SMC was replaced? This is actually a good time for the SMC to prove itself. If it is that one from the other board, if it is good or no. Okay, does it start? Okay, yeah, so it was good. Okay, now let's see, what do we have on PP340 is definitely present, otherwise the board did not start. 8.6, 8.2. Okay, you see what I'm talking about? We still have 8 point.
It's been going down.
Yeah, wait, what is that? Okay. Yeah. Okay, let's see what's happening on that resistor, because we know we had let's see, check here. Yeah, we have an issue there. Say we're getting 2 point something, and then the other one, the other side, 2.9. Let's see, it's supposed to have 2.9. Nah. Okay, so two things. If we're getting 2.9 here, it means we're getting proper pull up. Now 3.3, and then the other side 3.2, and now here still 2.9, and then playing around. SMC might not be there. Wait, 3.44. Yeah, it's fine. 8.1 and yeah, let's see, and let's just check here again. Now 3.4. Yeah, it's just playing around. And here 3.4 now. Okay, still 8.1. Should we take the SMC from the other board that we're busy with? Because we know we have 8.6 on that board, correct?
Mm-hmm.
Yeah, we have solid 8.6. That's also, yeah, I kind of feel like maybe we have, so it might just be that the sensor itself is, or why don't we check the second one, this one here, because remember this one fell off, why don't we just replace this one as well, the second one, because they were both those were two areas where there's been previous work. So let's replace the second one as well, because you never know if the first one was not properly, if it wasn't sitting in place as it should, who knows, the second one might as well. Yeah, it's replace that as well. Okay, let's replace. But before we replace SMC, at least let's replace both, so we're sure that's not the problem. We have a bridge between the two resistors, that's fine because they're on the same line. So you see that's a bridge between 1 and 2. It means they are joined, but that's fine because they're on the same line. And here, let me see what's happening there. Okay, that's fine. Nothing to worry about. So what I mean by that is here we have a bridge between R5381 and 5382, but at they are pin 1. They are pin 1 now of the same thing, not the pin 2s. Pin 2 are different. Pin 2 they are put SCL and SDA, but the pin 1 are sitting on the same line. So the bridge is fine, so we don't have to worry. So if the same bridge was on this other side, then that will have to separate. But being that the bridge is here, then it's fine. Do you understand what I'm saying? Okay, so let me see. Something, I don't know when did I saw. Let me see. 2. Okay, that's fine. Okay, that's fine. Let's check it again. Hopefully start at least. Okay, let's see what is it that we have on the SDA and SCL. can measure that here. 3.4, and on the other side 3.4. Not behaving as it was, but we don't know what do we have an SMC now? Alhamdulillah.
6.
Now we have 8.6. Now we should have a battery that is fully functional and detected. Now, but then that brings us to, what if the previous SMC was not the issue but the resistors? But then it was a bit tricky because we got the outputs from the resistors. I mean, yeah. So which means we just have to retain the SMC and then use it on another board and see. So let's quickly clean this. So yeah, but first thing I'm going to do is I'm just going to test it for you guys to see that we now have a battery that detects. And then in order for us not to have a too long video, I can always clean it afterwards. But right now, let's just get to test that. See that now we have a machine that detects the battery. We are going to connect minimal cables, only the cables that we require. Tripod, we require it. So we are going to connect the IO board cable. So the IO board cable, if it's not connected, the battery will not charge, but the battery will be detected. Do you understand? If this is not connected, the battery will not charge. However, the battery will be detected. So which means you can still power the machine on with the battery, and if you remove the charger with the battery being on, it's going to stay on. But if this is not connected, the battery is not going to charge. There will be no amber light, or there will be no LED communication at all. There will be no amber light, and then at the same time the fan will run crazy. But when that fan runs crazy, if it's because this is not present, the machine will not lag. Do you understand? The difference is, if the fan runs crazy because of a missing sensor, the machine will lag in that aspect. So let's just connect that. Oh yeah, the battery. So we have that, and then you should move to Ember, which is good. Let's wait for the machine to start. The machine is starting. Did it just go off on us? Okay. If you don't want to see this, you can just do a PRM reset, and it's not gonna behave this slow. Yeah, so it's and then so most likely we are going to, yeah, so see that? That's a beautiful battery, and if we are to restart the desktop, you should see a battery. I mean, before now you see on your recovery you don't see the battery sign, so let's now go to desktop. Should we just do a PRM reset one time so that, okay, but yeah, okay, so but now the battery is detected, but then you say something about, so that sign is a sign for service battery. Okay. But wait, so that's a sign for service battery. Let's just do a PRM reset, because you see the sign is different. Before it was X, correct? Okay, let's do a PRM reset. Let's just see that you have very rare occasions where you have battery issue, and then at the same time, which becomes a bit tricky sometimes to explain to the client that, hey, listen, you do have an issue with the board and the battery. Yeah. Okay. Okay, so we have that. Before it was X, correct? So what we're not going to do is we are going to test with another battery, and yeah, let's test with another battery. Yeah, I don't know how they're going to explain this to their client. They're saying, yes, we have a problem with the board, but at the same time, we have a problem with the battery. Or this could also be the test battery they put on to test it. Who knows? That could be the case. It could be that they put in this one to... So if this does exactly the same thing, then we know we have to worry about it. Even though we're making progress, now we have 8.6 on PB bus, which is good. And then we had battery detection. You see that? So that's a beautiful battery detection. So because we don't have the password, we are not going to see the actual battery. We're not going to see the actual battery icon, the power icon there. You know that. But what we are going to see is that is going to increase. So we are on 0% now. It's going to increase. So this is going to be tricky for them to explain to their client that yes, you have a problem with the board, and the board is fixed, but you still need to replace the battery. I'm not sure how that conversation is going to go. Yeah, but that's going to be a tricky one for them. Okay, yeah, your battery battery is also dead. But then again, if they paid attention to the details, they would see that the first time the battery was not detected, and then the second time it is obviously going to give you a sign of service battery, you know. And then something else, I'm just thinking now. So we can tell them, we can only explain to them from the logic of the board to say, okay, yeah, there's the SMC communication, this and then that and then that. But that makes no sense to them. As far as they're concerned, when I brought it in, battery wasn't holding power. Now, battery is still not holding power. But you're telling me you fixed it. How is that possible? By the way, this is going to take a while until you but definitely that is supposed to increase. So from 0, it's probably going to take a bit of time to get from 0 to 1, but from 1 continuous is going to be different. Remember, this battery is coming from that machine that didn't have PP3B42, which means the battery has been down for a very long time. So even the base charge from the battery will be missing. Do you understand? So it's going to take a bit of time to transition from, you know, from 0-ish to 1, but from that to 1 to it's going to be different. So we're just waiting for it to move. And then another thing with this is also if the machine was off, it will also charge faster compared to the machine being on. Yeah, so we just do a bit of explanation while we're waiting for it. So we had a case of SMC not running as it should, and as a result we were getting 8.2 here instead of 8.6. Let's see. So as a result, so you see where it says 8.6. And then we're getting 8.6 instead of we're getting 8.2 instead of 8.6. So what we had to do was to first, and then when we checked the other side of the board, because we mentioned, that we need to have 3.42 volt here, and the clock line as well as the data line of the battery to the SMC. When we got here, we saw there was a bit of previous work here. So the first thing we had to do was to remove the edge bonding. After removing the edge bonding, we did reflow on the SMC. That did not solve the problem. But before we did that, we saw that R5380 and 5381, there's been work there as well. But then we checked the output of it, which is we were getting 3.4 volt here and then 3.4 volt on the other side as well. So the first thing we did was, after removing the SMC, was to check to see that we have continuity between both parts. And then yes, we did find that we have continuity. So what we then had to do was to replace it, but then after replacing the SMC, R5380 fell off, which was good because the pads were not solid, and if it didn't fall off, we wouldn't have been able to tell. Because imagine if after replacing the SMC, which is exactly what happened, we replaced the SMC, the machine powers on, but still you have a case of the voltage running from 8.12 to even lower than that. So we decided we wanted to replace the SMC, but then we said, okay, wait, before replacing the SMC, why not just do the same thing to R5381? I mean, because 5380 was replaced, let's also do the same thing here. So we replaced R5381, and then we tested it, and now we started to have 8.6, and then now we see that the machine needs, now the machine detects the battery. Unfortunately, the battery for the client, it's somehow also an issue, from not being detected to detected but service battery, which would mean the client is still not going to be able to use the battery, and then we have to put in another battery which is detected, and it's still 0%. Okay, so this is most likely going to take some time to move from 0 to 1. Let's see. Another thing is, if you don't put in the password after waiting for some time, the timer, then the device will go off. That's also okay. So this is taking time to transition from 0 to 1. Yeah, so we might have to save our time, we might have to kind of shut it down. Alternatively, we can just get another battery, just so that you guys see that it's working. Let me see if I can get another battery. In case that is, but again, we can just give this a bit of time. Yeah, so, but again, just for the sake of time, let me see if I can get another battery. Yeah, it's Macbook here. I actually forgot about this one. What's up? Did you tell me about this? Yeah, so this is on 88%. So if we had to use this battery, for example, we should, this should charge faster compared to, just give it at least another 1 minute. Let's see. It's, yeah, so if you can just give it another minute by 5:47, then we can check to see if at least we have something happening there.
It's 47. It's 5:47.
47, okay, let's check it out. Okay, yeah. So now you see we now on 1%. So it's so from now on it should charge a little faster. So see that? Now we have 2. Can you see? Now we are now on 2. So if we remove the battery, the machine should stay on. Although I'm not sure how strong the battery itself is. So yeah, that's about it. We don't want to waste your time by having to clean it. So we can just clean it and then finalize the device. Thank you guys. I will see you guys. So that is basically how you go about your troubleshooting. So what you do, I'm just gonna, oh yeah, I see it's stopping. So let's show how strong the battery is. So in terms of repairs, the actions that you take, it's going to be dependent on what is it that it's what is it that determines your steps. Is going to be it's going to be determined by the state of the device. What you're getting at the time is what will determine what you do and the next step to take. So you have to really understand how your multimeter works and what you're supposed to have in the different phases and state of your board. That way you will be able to move quicker and faster. Okay, thank you guys. I will see you guys in the next one.